Morning. Today's topic in organic chemistry, structural theory in organic compounds. First, organic chemistry means it is a branch of chemistry which can deals the physical and chemical properties of carbon compounds are called organic chemistry. It is a branch of chemistry which can deals the physical and chemical properties of carbon compounds are called organic chemistry. Here in the organic chemistry, the first compound is urea, which is synthesized by Euler. Here, Euler synthesized urea from inorganic compound, that is ammonium cyanide. Ammonium cyanide, upon heating, it undergo rearrangement to give urea. This urea is the first organic compound synthesized by Euler. Therefore, Euler is the father of organic chemistry. Here in the structural theory in organic chemistry, first it explains the study of carbon and its compounds is known as organic chemistry. The structural theory gives us a better understanding about basic organic chemistry. Structural theory gives us a better understanding about basic organic chemistry. Here, the most of the organic compounds are covalent compounds. Most of the organic compounds are covalent compounds because here carbon atomic number 6, its ground state electronic configuration is 1s2, 2s2, 2p2. But in the excited state, the paired up s electrons are excited into the valence 2pz orbital. In the excited state, its electronic configuration is 1s2, 2s1, 2px1, 2py1, 2pz1. Here, carbon having 4 odd electrons in their valency cell, it can share 4 electrons from the hydrogen atoms. It can form methane molecule. Means here, generally, carbon is a element which can form some millions of organic compounds in the organic chemistry, because the special characters of carbon is first one is the valency of carbon is 4, second one high catenation power of carbon, third one is carbon have tendency to form multiple bonds between them. Here first valency. Valency means the number of odd electrons present in the outermost shell of an atom is called its valency. First, valency means the number of odd electrons present in the outermost shell of an atom is called its valency. Here, carbon excited state electronic configuration 1s2, 2s1, 2px1, 2py1, 2pz1. It have 4 odd electrons in their valency cell. Therefore, carbon exhibit 4 valency in the organic compounds. Second one is high catenation power of carbon. Here, catenation power means the self linkage of the similar atoms to form a longest chain compounds is called catenation power. The self linkage of similar atoms to form a longest chain compounds is called catenation power. Carbon have highest catenation power element. Therefore, it can form some millions of organic compounds in the organic chemistry. Third one is formation of multiple bonds. Here, carbon have tendency to form single, double, and triple bond between the carbon atoms. Carbon can form single bond with carbon, resulting the formation of alkanes. Carbon have tendency to form double bond, multiple bonds. Among the double bond, one is sigma bond, another one is pi bond, resulting the formation of alkenes. Carbon have tendency to form triple bond between the carbon atoms. Among this triple bond, one is sigma bond, the rest of two are pi bonds. It can form alkynes. Here, due to this, the special characters of carbon, that is, one is valency of carbon is 4, second one is high catenation power, third one is formation of multiple bonds. Carbon form some millions of organic compounds in the organic chemistry. Here, all organic compounds are called covalent compounds. Why means here carbon having 4 odd electrons in their valency shell. It can share 4 electrons from the hydrogen atom to form methane molecule. Here the mutual sharing of electron pair by two atoms resulting the formation of covalent bond. Here first covalent bond means it is formed between the two atoms by mutual sharing of electron pair. This covalent bond is classified into two types. One is the non-polar covalent bond. Second one is polar covalent bond. Here first non-polar covalent bond means generally in the homoatomic molecules. Homoatomic molecules means the mutual sharing of the electron pairs by the two similar atoms. For example, hydrogen. Two hydrogen atoms can share one electron pair, formation of hydrogen molecule. Similarly, two chlorine atoms can share one electron pair, it can form chlorine molecule. Then nitrogen molecule, then bromine molecule, iodine molecule, etc. The mutual sharing of electron pair by the two similar atoms resulting the formation of non-polar covalent bond. Because here if the bond pair of electrons lie exactly in the middle of two bonded atoms, then it is known as non-polar covalent bond. Once again, here the non-polar covalent bond is exist in the only homoatomic molecules. Homoatomic molecules means the molecules which are sharing electron pair by the two similar atoms. Example, hydrogen, nitrogen, oxygen, chlorine, bromine, iodine, etc. Here, if the bond pair of electrons lie exactly in the middle of two bonded atoms, then it is known as non-polar covalent bond. Example, hydrogen, chlorine, bromine, etc. Next, second one is polar covalent bond. This polar covalent bond exists in the heteroatomic molecules. Heteroatomic molecules means the mutual sharing of electron pair by the two different atoms, resulting the formation of heteroatomic molecules. Example, formation of HCl, formation of ammonia, formation of water, etc. Here, if the bond pair electrons lie nearer to the more electronegative atoms, not in the middle, then it is known as polar covalent bond. Once again, here polar covalent bond exists in between the heteroatomic molecule. Heteroatomic molecules means the mutual sharing of electron pair by the two different atoms, resulting the formation of heteroatomic molecules. Example, hydrochloric acid, HCl, water, ammonia. Here, in the if the bond pair electrons lie nearer to the more electronegative atom, not in the middle, then it is known as the polar covalent bond. Example, HCl. Among the HCl molecule, the electronegativity of hydrogen is less than chlorine. Means due to the more electronegativity of chlorine, these bonded electrons are polarized towards the chlorine atom. Therefore, here chlorine gets partial negative charge, hydrogen gets partial positive charge. It is called polar covalent bond. Here, the development of charge due to the movement of electrons towards more electronegative atom in a polar covalent bond is known as polarization or electrodisplacement. Once again, the development of charges due to the movement of electrons towards more electronegative atom in a polar covalent bond is known as polarization or electrodisplacement. Here, the effect that cause polarization are called as polarization effect. Here, there are three important polarization effects are there in the covalent molecules. One is inductive effect. Second one is mesomeric effect or resonance effect. Third one is hyperconjugation effect. First, inductive effect. Second, mesomeric effect or resonance effect. Third one is hyperconjugation effect. Here, first one is inductive effect. It is important one. In a polar covalent bond, electron pair is attracted towards more electronegative atom is called inductive effect. Once again, in a polar covalent bond, electron pair is attracted towards more electronegative atom is called inductive effect. For example, in the CX bond, C is the carbon, X is an halogen atom. The electron here among this CX bond, the compared to carbon, the electronegativity of halogen is more. Therefore, the electron pair is attracted towards halogen. So, X gets partial negative charge and carbon gets partial positive charge. It is called inductive effect. Or it can also defined as the displacement of sigma electrons. Once again, the displacement of sigma electrons towards more electronegative atom along the carbon chain is known as inductive effect. We can define either of one first inductive effect means in a polar covalent bond, electron pair is attracted towards more electronegative atom is called inductive effect. Or it can also defined as the displacement of sigma electrons towards more electronegative atom along the carbon chain is known as inductive effect. The main characters of the inductive effect is first one, it is a permanent effect. It is permanent effect. Second one, it is denoted by the symbol from a arrow from lower electronegative atom to higher electronegative atom. It is denoted by the symbol, that is the arrow from lower electronegative atom to higher electronegative atom. Like here carbon, chlorine. Here the polarization towards chlorine atom. Here chlorine gets partial negative, carbon gets partial positive charge. Third one is consider a carbon chain with more electronegative halogen atom as its terminal. The halogen atom is terminal of the carbon chain. Fourth one, since the halogen is more electronegative and bond pair of electron in CX bond are attracted towards halogen, so X gets partial negative charge and carbon gets partial positive charge. Here that is halogen gets partial negative charge and carbon gets partial positive charge. Fifth point, since carbon is positively charged, it attracts the electron pair between C2 to C1 bond. So C2 gets positive charge, but the charge on C2 is less than C1 atom. Sixth point, the effect of halogen atom is transmitted throughout the carbon chain. The effect of halogen atom is transmitted throughout the carbon atom. Then seventh point, the after 4 carbon atoms, inductive effect is negligible. After 4 carbon atoms, inductive effect is negligible. Based on the electron withdrawing as well as electron releasing nature of the atom, the inductive effect is classified into two types. Once again, based on the electron withdrawing and electron releasing nature of the atoms or groups, inductive effect is classified into two types. One is the negative inductive effect, that is called minus inductive effect. Second one is positive inductive effect or plus psi effect, plus inductive effect. First one, negative inductive effect. Here, negative inductive effect means the groups which are more electronegative than hydrogen are classified as minus inductive effect groups. Once again, the groups which are more electronegative than hydrogen are classified as minus inductive effect groups. Example, fluorine atom, bromine, iodine, carboxylic group, aldehyde group, nitro group, sulfonic acid group, etc. These groups attract the electrons from the carbon chain. These groups attracting the electrons from the carbon chain. Hence, these are also known as electron withdrawing groups. The order of groups exhibiting minus inductive effect or electronegativity of groups is nitro group is greater than, fluorine is greater than, carboxylic group is greater than, chlorine is greater than, bromine is greater than, iodine is greater than, hydroxyl group is greater than, ether group. Or here the effect that is caused due to the presence of electron attracting or electron withdrawing groups is known as minus inductive effect. Once again, the effect that is caused due to the presence of electron attracting or electron withdrawing groups is known as minus inductive effect. Once again, the effect that is caused due to the presence of electron attracting or electron withdrawing groups is known as minus inductive effect. Second one is positive inductive effect or plus psi effect. The groups which are less electronegative than hydrogen are classified as positive inductive groups. The groups which are less electronegative than hydrogen are called classified as plus inductive effect groups. Example, that is methyl group or ethyl group, isopropyl group, tertiary butyl group. Here, these groups gives the electrons to the carbonations of the chain in the molecule. Hence, these groups are also known as electron releasing groups, or it can also defined as the effect that is caused due to the presence of electron donating. The effect that is caused due to the presence of electron donating or electron releasing groups is known as plus inductive effect or plus psi effect. Example, tertiary butyl group is greater than, isopropyl group is greater than, ethyl group is greater than methyl group. or simply it can say tertiary alkyl group is greater than secondary alkyl group is greater than primary alkyl group is greater than methyl group. The important applications of inductive effect or the importance of inductive effect is this inductive effect can explain the basicity of amines. Second one, acidity of carboxylic acids. Third one is stability of carbonium ions. Once again, the important applications of inductive effect is it explains the basicity of amines. Second one, acidity of carboxylic acids. Third one is stability of carbonium ion. First one is basicity of amines. Generally, the basicity of amines can be shown by the following equation. That is, amine general formula is RNH2 plus water, double decompose it to give RNH3 plus OH minus. Here, amines act as bases. Why means generally here in the amines, due to the presence of lone pair electrons on the heteroatom nitrogen, it can easily accept proton. According to here the according to Bronsted-Lowry acid base theory, proton acceptor is called Bronsted base. In the amines, the heteroatom nitrogen having lone pair of electrons, it can easily accept proton. According to Bronsted-Lowry acid base theory, proton acceptor is called Bronsted base. Therefore, amines exhibits the basic character. First point. In the second point, according to Arrhenius acid base theory, in the aqueous solution, hydroxide ion donor is called base. Here in the amines, actually the amines can easily accept proton from the water. In the double decomposed equation, it gives RNH3 plus OH minus. In the aqueous solution, hydroxide ion donor is called base. Therefore, it exhibits the basic character. Amines exhibits the basic character. Similarly, according to Lewis theory, here according to Lewis theory, electron pair acceptor is called Lewis acid. Electron pair donor is called Lewis base. Here in the amines, the heteroatom nitrogen having lone pair of electrons. It can easily donate pair of electrons to the electron deficient proton to form coordinate covalent bond. According to Lewis acid base theory, proton, the electron pair donor is called Lewis base. Therefore, amines exhibits the basic character. Here, amines act as bases because they are proton acceptors. In amines, a lone pair is present on nitrogen like ammonia. It can donate its electron pair to the electron deficient substances and hence act as bases. Any group, if increase the electron density at nitrogen increase the basicity, because the electron density, because nitrogen atom can easily react with the electron deficient substance. In general, the plus inductive effect groups increase the electron density on nitrogen atom. Therefore, the basicity of amines increases. Means if the nitrogen which attached to the plus inductive effect groups which increase the electron density on nitrogen atom, it can increase the basicity of amine. Similarly, In contrast to this, the nitrogen which have attached to the electron withdrawing groups like minus inductive effect groups decrease the electron density on nitrogen atom. Simultaneously, it can decrease the basicity of amines. Here, the relative basicity of ammonia derivatives and ammonia can be explained by inductive effect. Here, the increasing order of basicity is here Cl, CH2, NH2, amino chloromethane, which is less basic than ammonia, which is less basic than methylamine, which is less basic than dimethylamine. Because in the first molecule, due to the electron withdrawing nature of chlorine atom, electron withdrawing means minus inductive effect nature of chlorine atom, the electron density on nitrogen decreases. Simultaneously, the basicity of this molecule is less than ammonia. In the second one, then the ammonia is less basic than methylamine because in the methylamine, due to the presence of electron releasing nature of methyl group, means the plus inductive effect nature of methyl group, it can increase the electron density on nitrogen atom. Therefore, the basicity of methylamine is more than ammonia. Next, compare with methylamine, the basicity of dimethylamine is more basic than methylamine because in the dimethylamine, due to the presence of two plus inductive effect methyl groups, the electron density on nitrogen increases. Therefore, its basicity of dimethylamine is more than methylamine. That is the basicity of amines. Next, its a comparison. Secondary amines are more basic than primary amines and tertiary amines because in secondary amines there are two plus inductive effect alkyl groups. The alkyl groups increase the electron density on nitrogen atom. So the lone pair of electrons are more easily donated by the nitrogen atom. But in primary amines, there is only one plus inductive effect alkyl group. So the electron density around nitrogen is less when compared to the secondary amine. But in tertiary amines, the three bulky alkyl groups cover the lone pair of electrons on nitrogen. So due to the steric hindrance, the lone pair of electrons are not easily donated. Therefore, here the tertiary amines are least basic when compared to the primary and secondary amines. The order of basicity of amines is secondary amines is greater than primary amine is greater than tertiary amine. That is dimethylamine is more basic than methylamine, which is more basic than trimethylamine. Here trimethylamine is the that is trimethylamine is called tertiary amine. In the tertiary amine, due to the presence of these three bulky methyl group here, which is covered by the electron cloud, the lone pair of electrons on the nitrogen atom. Therefore, it doesn't donate the pair of electrons. Then its basicity is less than primary and secondary amines. Next, acidity of carboxylic acids. Generally, carboxylic acids exhibit acidity by losing proton, and acidic strength depends on the stability of forming conjugate base, that is carboxylate ion. Here, formic acid is more acidic than acetic acid because it can be explained by inductive effect. Formic acid is HCOOH. There is no plus inductive effect group on formic acid. Here by the donation of proton by the formic acid, it gives the more stable formation. Hc double bond O minus is the more stable formation due to its resonance stability. But in acetic acid, due to the presence of plus inductive effect methyl group, here the stability of acetate ion is less. Therefore, in acetic acid, the plus inductive effect methyl group repelling electron towards the carboxylic group. So the electron density on hydrogen increases and proton ion is not easily released. But in formic acid, there is no plus inductive effect group, so it can easily release proton H plus ion. Hence, formic acid is more stronger acid than acetic acid. Next, chloroacetic acid is more acidic than acetic acid because it can explain by here in the chloroacetic acid, the chlorine atom is minus inductive effect. Electron withdrawing nature of the chlorine atom. Here it exhibits the minus inductive effect or negative inductive effect. Chlorine attracts the electrons from the methylene group, that is CH2 group, and form COOH group. So the electron density on hydrogen decrease and H plus ion is easily released. But in acetic acid, due to the plus inductive effect nature of methyl group, repels electrons towards the carboxylic group. So the electron density on hydrogen increases and H plus ion is released slowly. Hence, chloroacetic acid is more acidic than acetic acid. Third application, trichloroacetic acid is more acidic than dichloroacetic acid and chloroacetic acid. It can be explained by inductive effect same. In the trichloroacetic acid, due to the electron withdrawing nature of these three chlorine atoms minus inductive effect nature of these three chlorine atoms, the electron density on proton is decreases simultaneously. It can release proton H plus ion easily than dichloroacetic acid and chloroacetic acid. Therefore, here the inductive effect and acidity decrease with the decrease in number of halogen atoms. So, trichloroacetic acid with more halogen atom is a stronger acid when compared to the trichloroacetic acid and monochloroacetic acid. Next, fluoroacetic acid is more acidic than chlorobromoiodoacetic acid because in the halogens, fluorine is more electronegative than chlorine, which is more electronegative than bromine, which is more electronegative than iodine. Therefore, in the fluoroacetic acid, fluorine is more electronegative than chlorine, bromine and iodine atom. Fluorine has a strong minus inductive effect group. The acidity increase with increase in minus inductive effect and electronegativity. Hence, fluoroacetic acid is more acidic than chloroacetic acid, which is more acidic than bromoacetic acid, which is more acidic than iodoacetic acid. The last factor is stability of carbonium ion, carbocation. Here, due to the plus inductive effect, the alkyl group release electrons towards positive carbon atom, carbonite, thus reduce its positive charge. This is called charge dispersal. Again, due to the plus inductive effect, alkyl group release electrons towards positive carbon and thus reduces its positive charge. This is called as charge dispersal. In the tertiary carbonium ion with three alkyl groups has more charge dispersal. So it is more stable when compared to the secondary carbonium ion with two alkyl groups and primary carbonium ion with one alkyl group. Here methyl carbonium ion with no alkyl group is least stable. In the tertiary, butyl carbonium ion is more stable than isopropyl carbonium ion is more stable than ethyl carbonium ion is more stable than methyl cation or methyl carbonium ion, because here in the tertiary carbonium ion, due to the 3 plus inductive effect methyl groups, here the positive charge on the carbon decreases. Simultaneously, here no bond resonance can affect the stability of carbonium ion. It can form 9 resonance structures. Here, in the tertiary carbonium ion, one is the methyl, 3 methyl groups containing 9 hydrogen atoms. It can form 9 no bond resonance structures. It is more stable. But in isopropyl carbonium ion, here due to the presence of these 6 hydrogen atoms, it can form 6 no bond resonance structures. Then it is more stable than ethyl carbonium ion having 3 hydrogen atoms. It can form 3 no bond resonance structures. But methyl carbonium ion doesn't contain any alpha hydrogen atoms. It doesn't form any no bond resonance structures. Therefore, tertiary butyl carbonium ion is more stable than secondary isopropyl carbonium ion, is more stable than ethyl carbonium ion, is more stable than methyl carbonium ion. Thank you.